Hi everybody, we continue to review counter algebra. We're going to use the calculator a lot, so I put the calculator on that side permanently. Right. The first few questions we just do the matrix operation. First one, 4 times matrix A plus B. We do this one by hand first. So 4 times matrix A plus B. 4 times the matrix A is 3, 3, 2, and 5. The matrix B 0, 4, negative 1, and 6. And auto operation, multiply first. So 4 times everything in the matrix. 4 times 3, that's 12, 12, 8, and 20. And then we have 0, 4, negative 1, and 6. And then we just add them, 12 and 0, so that's 12, 16, 7, and 26. So that's what we do by hand. If we use the calculator, there's two ways to do it. You see, first of all, we see the matrix above the x to negative 1 here. This is the longer way though. Second matrix. First, if we go do it this way, we have to store the values into the matrix. So highlight the edit and hit enter. And then this is a 2 by 2. 2, enter, 2. And then we'll just enter the values 3, 3, 2, and 5. So that is the matrix A. And then second mode, back to the home screen, and then second matrix again. Now you see the matrix A is there. We will go to edit again. When we're in the edit mode, we can input the matrix. So go down to 2, and this is also 2 by 2. 2, enter, 2, enter. 0, 4, negative 1. Notice the negative 1 is here, not the subtract. It looks different, you see. Negative 1, enter, and 6, enter. Right, once we're done, second mode. So we hit second matrix. On the names, we see there are 2 matrices. If we want to input, it will be in the edit tab. If not, in the names. Right, in the names we can recall the matrix, for example. That gives us the matrix A on the home screen. Right, so we have 4 times the matrix A, second matrix. Under the names, we call the matrix A, and then plus the matrix B, second matrix. Go down to 2 and call the matrix B. Of course, we're going to have that. Right, that is the long way to do it. If your calculator can do this option, I recommend that we'll do it this way. If you hit alpha and zoom, and the bottom menu pop up like that, that means we can do it. So this is a 2 by 2. So okay, now it's very important in this mode, everything in the home screen, we don't hit enter. We do not hit this button until we're done. So 3, we're just going to hit next. We'll do the next one, 2, and 5, for example. Right, let's do that again because I forgot the 4. Right, 4 times alpha, zoom, 2 by 2. That's good. That's okay. And then we store 3, 3, 2, and 5. And then, like I said, don't hit enter. Plus another matrix, so alpha, zoom, 0, 4, negative 1, and 6. Once we're done, we just hit enter to get the answer, and that is what we have. So pretty much just that. Next, solve the matrix equation. Now this is simple. X plus A equal to B. If we want to solve for x will be equal to B minus A. So just take the matrix B minus the matrix A. So B is 3. 3, -4, 4, -5, minus matrix A, 4, 2, 3, and 5. So just subtract the corresponding entry. 3 minus 4 is -1, -4 minus 2, -6, 4 minus 3, 1, -5 minus 5, -10. Right, let's use the calculator to confirm it. Alpha zoom 2 and 2, that's good. 4, B minus 8, 3, -4, 4, -5, and then subtract. If this happened to, for example, we have 4 and you forgot to just hit enter, and that, because that's not right, we haven't finished entering. But don't worry, we just go up there, highlight it, hit enter, so we'll copy and paste. Now we can continue working on our problem. 4, 2, 3, and then 5. Of course, that's what we get, so that's good. Right. Next we have the matrix multiplication. Matrix multiplication a little more complicated. We just need to make sure that first is the dimension. So the matrix A is 2 rows, 3 columns. 2 rows, 3 columns. The matrix B is 2 by 2. Since the middle numbers do not match, the product does not exist, so we say AB does not exist. The middle number have to be the same. Right. So that's what we say about that problem. Does not exist. Sorry. Right. Next, A times B. A is a 2 by 2. B is a 2 by 3. The middle numbers do match, so this is good. The product exists, and so we have AB. The product is going to be the outside numbers. It's going to be 2 by 3. So we write the problem A times B. That is A, and then B, 0, -2, 5, 1, -3, and 2. We know that when we multiply, it is going to be a 2 by 3. And then for each entry here, we just use the row from the first matrix and the column from the second. Right, the row from the first matrix, the column from the second matrix. For example, if I want this entry, this is on the first row, first column. So the row from the first matrix, the first row on the first matrix, and the column from the second matrix. And there are 2 on each. So first with the first, second with the second, and then we add them. So that gives us 3. Right. Let's just pick a random entry. Let's see if I want this entry. This is on the second row, second column. So we use second row and second column. So 1 times negative 2 plus 4 times negative 3. So negative 2, negative 12, that's negative 14. Like I said, I just pick a random entry. How about this one? This one on the first row and the third column. So the row from the first matrix, the column come from the second matrix. So we have negative 1 times 5 plus 3 times 2. So that is negative 5 plus 6, so that is 1. Right. The rest, of course, we can just do that, but we can also use the calculator. Alpha zoom 2 by 2 is the first one, which is okay there. Negative 1, 3, 1, 4, alpha zoom. Right, 0, negative 2, 5, 1, negative 3, 2, right, 3, negative 7, 1, 4, negative 14, and 13. Right, so that's pretty much it. Next, try the inverse of a 2 by 2 matrix. That is easy. If A is the matrix of A, B, C, D, then A inverse is equal to 1 over AD minus BC. A and D here, these two we interchange the places, so D goes here and A goes here. And then the other two entry we just negate it, so negative B, negative C. Right. That is the inverse of a 2 by 2 matrix. Of course, it only exists if AD minus BC not equal to 0. Because divide by 0 is undefined, and therefore the inverse will not exist. Right. So based on that, the matrix A inverse is going to be 1 minus 6 negative 6 times 5 minus negative 2 times 0, and then times negative 6 and 5 interchange, 5 and negative 6. Interchange the places, and then 0 and negative 2, we just negate. So that gives us 1 over negative 30, 5, 2, 0 and negative 6. And multiply that inside, we will have negative 1 over 6, negative 1 over 15, 0 and 1/5. Of course, we can also use the calculator. We have a 2 by 2 here. Negative 6, that negative sign. Negative 2, 0 and 5. The inverse is going to be this button to that one. And of course, not quite that, but we can always change the fraction. So hit math, convert to fraction, and yeah, that's what we have. Right. Next, write the linear system as a matrix equation. So that's easy. The matrix equation is in this form: AX equal to B, where A is the coefficient matrix, X is the variable matrix, and B is the constant matrix. And the constant is on the other side of the equation here. So we're going to have 3, 8, 0, and 6. Those are the coefficients. Notice that here we can write 0x like that. So 3 and 8, 0 and 6, those are the coefficients. That's A. X, variable X and Y. And then we have 48 and 18. In this problem, that's what they want us to do. Next, on this one, we actually have to solve for it. So solve the system of equation using the inverse. Because on this one, they give us the inverse. But we just use a calculator. That doesn't because in this problem. Right, first, we have AX equal to B. So A is the coefficient matrix. We have 1x, 2y, 3z, 1x, 1y, 1z, 2x, 2y, 1z. So this is the coefficient matrix. Next, the one variable x, y, and z. And then the constant -4, 1, and -5. And that is the matrix equation. We have A, X equal to B. Now if AX equal to B, then X equal to A inverse B. So we just take the inverse of matrix A times B. So that's why the matrix, the inverse is given. We don't even need that if we have the calculator. Alright. Again, alpha zoom, this time is the 3 by 3. Oops. One, 2, 3, 1, 1, 1, 2, 2, 1. So that is matrix A. Now we're just going to do the inverse. And then alpha zoom again. The second matrix is 3 rows, 1 column, 3 by 1. -4, 1, and -5. Right, so we just have -13, -19, and 7. That is x, y, and z. We can write as x, y, and z. Oops. So the set of these 3 numbers is a solution. Right, so that's all we do there. Determinant 3 by 3. There's a lot of different ways to do this. Since we have a calculator there, I'm just going to use it. So second matrix. Perhaps we'll have the matrix there. Go to math. The first one is DET, which is determinant. And then a 3 by 3, so just alpha zoom. And then we just enter the matrix. So -4, 1, and 2, -1, 0, and -2. Five, 0, and 1. Close. It is -9. Right. If we want to do that by hand, we will have -1, -4, 1, 2, -1, 0, and -2, 5, 0, and 1. This is only work for a 3 by 3 matrix. So what I'll do is I copy the first two columns. So copy -1, 4, -1, and 5, 1, 0, 0. And then we will have 3 diagonal. 1, 2, 3. This diagonal will carry the positive sign, and then the other 3 carry the negative sign. So the first one, -4 times 0 times 1, that's 0. Next one, 1 times -1 times 2, that's -10. Next, 2 times 1 times 0, that's 0. So those are positive. The other direction, 2 times 0 times 5, that's 0. -4 times -2 times 0, still 0. And 1 times -1 times -1, that is -1, but this is negative. And so we, of course, also have -9. And there's another way to do that using the cofactor, but I'm going out. Right, next, use Cramer's rule to solve this system of equation. If you don't want to use Cramer's rule, we can also use the matrix equation like this. Works perfectly. It should be the same. But on this case, we're going to use the Cramer's rule. So for Cramer's rule, we need to have the 3 determinants. First, the determinant of the coefficient 5, 4, 2, and 1. So do that. 5 times 1 minus 2 times 4, that is -3. So that is D. Now we're going to have dx. We'll put that in x. Right. For dx, this is going to be similar to this, except instead of 5 and 2 coefficient of x's, we replace the last 2 into the x's column, if you will. So put -8 here and -5 there. Replace the x's with the last column with the constant. So put 1 and 4 and 1 still. So -8 times 1, -4 times -5. So that is -8 plus 20. -8 plus 20, that is positive 12. And then dy, that is lowercase. So we have that. But instead of the coefficient of y, we use the constant. So -8 and -5. So 5 times -5, subtract -8 times 2. Right, 5 times -5, that's -10, plus 16, so that is 6. No, that is 25, sorry. -25 plus 16, -25 plus 16, that's -9. -9, sorry. And then finally we will have x equal to dx over d, y is dy over d, dx over d, 12 over -3 is -4, dy over d, -9 over -3 is 3. So the solution x, y equal to -4 and 3. Or we can write that in the set of -4 and 3, like that. Next, go to the sequence and series. Sequence. Write the first 4 terms of the sequence whose the general term is given like this. This one is fairly simple. We need the first 4 terms. So first we're going to put 1 in for n. That gives us -1 times 7, -7. Next we're going to put 2 in for n. So that 1 and 2, that could be 8. And then put 3 in for n. That is 10. So that's pretty simple. If we want to use the calculator, hit mode. We'll see here we have function, parametric, polar, and sequence. If we want sequence, we'll give that, keep at number 4, and then quick. Now when we hit y equal 2, we're going to have that. The first one is 1, that's good. And then we have -1 raised to the power of -1. Sorry, -n. So now that n is going to be this, which corresponding to function, parametric, polar, and sequence. So see the calculator in the 4th mode, the sequence. When we hit this button, that gives us the n. And then we have n, n plus 6. And then we hit second table, and we have the values. So that's very simple. Right. Next, the first 4 terms. This is the recursion formula. So the first term is given, so we have a1 already. Now to get a2, n is equal to 2, we have a2. Now if we put 2 here and here, we will have 2 minus 1 minus 5. a2 minus 1 is a1 minus 5, and a1 is 5. And substitute this into here, and we have 0. Now n equal to 3. 3 minus 1 minus 5. So a2 minus 5. a2. Substitute that in here, we have 0 minus 5 is minus 5. And the same thing, we can get n equal to 4. And certainly we can get that. 4 minus 1 is a3 minus 5. a3 is -5 minus 5 is -10. Right. If we have the calculator, we hit y equal 2. We're going to enter exactly that. I mean, not exactly. Have to write a little bit differently. So we have a sub n equal to a sub n minus 1 minus 5, meaning that this term is equal to the previous term minus 5. So if we write in the calculator, it will be u of n equal to u of n minus 1 minus 5. So this term is equal to previous term minus 1. So the u is above the 7, so we hit second 7 of n minus 1 minus 5, right? And then the first term we know is 5, right? So recursion is going to be like that. And second table, we have the values 5, 0, -5, and -10, and so on. Right. Next is the sum. So this means I will be equal to 1 to 5, increasing by 1 every time. So first we're going to put 1 in it, and we're going to put 2 in it, 3 in it, 4, and then 5. So that gives us 3, 4, 5, 6, and 7, 25. Right. So again, calculator, if we can use it. Hit math, we have to go to the summation here, and we can use any variable. Let's use n equal to 1, go to 5, and then the expression is n plus 2. So of course 25. Right. Let me write a timestamp. Right. Next we have the common difference. Now we go to arithmetic and geometric sequence. Arithmetic sequence. Look at this sequence. It is increasing by 4 every time. So just adding 4 every time. So that is the common difference. It's going to be 4. So that's what we do on that problem. Right, next, 5a upon 40, so that's easy. Right, the next few problem, this is general term, so the n term, arithmetic sequence. We're going to do that. an equal to a1 plus n minus 1 times d. So the first term plus n minus 1 times d. So let's take a look at the last problem real quick. So we start with the first term. If we go to the next one, we take a step, and every step is a plus 4. If we want to go to the third number, we're going to take 2 steps. If we go to the fourth number, we're going to take 3 steps. So if we want to go to the nth number, we're going to take n minus 1 step, and this step is a difference. So that's what we have. So now if we have 140 in for n, a1 is negative 4. N minus 1, 140 minus 1 times the difference 3. So we have negative 4 plus 139 times 3. And so that gives us 139 times 3 is 407 minus, 417 minus 4, 413. Right. So again, just that formula. In that formula, of course, we need to know the first term, where we start, and the difference. How do we get from this term to the next? Right. Again, we're going to write the general term, which is this arithmetic sequence, and then find a of 20. So on this sequence, we know that the first term is 4. That's obvious. The first term is 4. And to get from this one to the next, we're going to add 8. So the common difference is 8. Once we know those two, we write a sub n equal to a sub 1 plus n minus 1 times d. So a of n, a1 we start with 4, and n minus 1 times d is 8. So we have 4 plus, multiply out an minus 8. Combine like terms, we have a sub n equal to an minus 4. So that is the general term of an arithmetic sequence. And then after that, we have to find a of 20. So put 20 in for n. 160 minus 4 is 156. Right, so that's what we have there. Now next we have the sum of arithmetic sequence. The formula is this one. So number of terms divided by 2, the first term plus the last term, right? Right. So we know that there's the first 20 terms. So n is equal to 20. The first term we know is 7. We just don't know the 20th term. Right. To do that, it's very simple. We still have a sub n equal to a1 plus n minus 1 times d. A of 20th, a20. The first term is 7. To get to this, to the next one, we're going to minus 6. And it's 20 minus 6. Do that. We have 7 times 19, 7 plus 19 times negative 6. 19 times 26, 120, 120, 114. We have a calculator. Why don't we just use it? 7 plus 19 times negative 6. Negative 107. That is a of 20. And we combine this. 20 over 2 is 10. 7 minus 107. That's 100. 10 times 100, so that is negative 1000. Right. That's what we have. Right. Next we go to geometric sequence. Geometric sequence, an is starting from the first one, but this time the ratio a1 times r to the n minus 1. So the common ratio is where we go from this to the next, and what we have to multiply by. This one we need to multiply by 4. So that is the common ratio. The number that we multiply to get from this term to the next. Right. Right. Next, write the first 5 terms of geometric sequence. So we start with a1 is 6. And then a2 is 1/4, so we multiply by 1/4. If we multiply by 1 over 4, 6 times 1 over 4 is 6 over 4, 3 over 2. And then a3, we're going to take this, multiply by 1/4. So it'll be 3 over 8. And multiply by 1 over 4. That will be 3 over 32. That a4. And then a5. Just multiply by 1/4. 3 over 128. So we have 6, 3 half, 3 8, 3 over 32, and 3 over 128. And those are the first 5 terms of that geometric sequence. So we just need to know the first one, and then we just get to the next one by multiply by the common ratio. So we haven't used this one yet. The next one we do. Right, 584. So again, let me write that formula again. H of n equal to a1 times r to the n minus 1. So we want 4 terms, so n equal to 4. The first term is 4. Common ratio is 3 to the 4 minus 1. So 4 times 3 cubed. 3 cubed is 27. 27 times 4, 108. Right. Next, for the sum of the first 11 terms of the geometric sequence. So either we use this one, we have r to the n minus 1 to the r minus 1, or we use the first term, 1 minus r to the n over 1 minus r. So either one of them works. In this case, we want 11 terms. This is the geometric sequence. From that sequence, we get the first term is 2. We will multiply by 2 to get to the next one. And then so the sum of the first 11 terms equal to the first term is 2 times r to the n. The ratio is 2 to the n power 11 minus 1 divided by 2 minus 1. By the way, I'm using this one. So the first term is 2, 2 to 11 power minus 1 over 2 minus 1. 2 minus 1 is just 1, so we have 2. 2 to 11 is 2048 minus 1, 2047 multiplied by 2 is 4094. Right, that's what we do. The next one is the sum of infinite geometric series. We start from the first term over 1 minus r. So that's good and all. But the ratio has to be between, not equal to, just less than, greater than 1, greater than negative 1, and less than 1. So pretty much between negative 1 and 1. Right. So this sequence, this series, the first term is 1, it's 5, which is good. Now to get to the next, this term to the next, we have to multiply by negative 1/3. If we don't know what it is, we can get r equal to a2 divided by a1 or a3 divided by a2. Just divide backward, pretty much. So r is 2 divided by 1, so we have negative 5 over 3 divided by 5. Multiply reciprocal, 1/5 is negative 1/3. So we have the sum is equal to, the first term is 5, 1 minus, the ratio is negative 1/3, so 5 over 4/3. Multiply reciprocal, 5 times 3 over 4, 15 over 4. Right. The next one is also a geometric series if we rewrite like this, 0 0.45, 45, 45, 45, and so on. We can write as 0.45 plus 45 plus 0.000045 plus, so it's like that. This infinite geometric series, the first term is 0.45, and the common ratio, we take this divided by the previous one, or this divided by the previous one. Anything we do. 0.0045 divided by 0.45 equal 0.01, and then the sum is A1 over 1 minus R. Before we do that, this ratio is bigger than -1 but less than 1, which is good. We have to check that first. Make sure the ratio is between -1 and 1, and then we just put in the formula. A1 0.45 1 minus R 0.45 0.99. Move the decimal point 2 places to the right. 45 over 99. Both are divisible by 9, so that would be 5 over 11. Next we have binomial expansions. So there are quite a few ways to do it. I've used in this method with the help of the calculator. Right. So first, binomial expansion. We have 3 components. The first one is the first term. In this case, it will be 3x. So what we do is we write in a bunch of columns. So we have 3x. Let's just divide into a bunch of columns first. Right. So the first one we're going to take, the first term is 3x, the second term is 2. Binomial means there will be 2 terms, the first and the second, and then of course the power. So we have 3x, the first term. We will take the first term raised to the power of that and reducing power. That's all. Now just do that. 3 cubed is 27x cubed. That is 9x squared. That is 3x, and anything we do 0 power is 1. That's the first term. Next, the second term is 2. Actually, we're going to take the positive 2. Now, the first one is decreasing power from the highest power. Now, this one will be increasing power. Now, let's do that. 0 power is 1. 2, 4, and then 8. And then next, the coefficient. The coefficient, I'm going to use the calculator here. There's quite a few ways to write the binomial coefficient, but I'm going to use C. And then just like the calculator, we're going to put 3 and then 0, 3, 1, 3, 2, 3, and 3. So the first numbers are the same, which is that 3, and then the second one will be increasing from 0 to that number. Right, calculator. So that is actually the combination. If we hit math, go to the probability tab. option number 3, combination. Right, so we need to hit 5 first, NCR and 0. So that gives us 1. And then go up, highlight that, change the 0 to 1. That is, I don't know why I put the 5 in front of it. It should be 3, right? 3. 2. If you don't want to do that and just have to go up and down a few times, just do this. First we hit 3, right? And then math, probability, option number 3, NCR, and then open parentheses, second parentheses, 0, 1, 2, 3, 0, 1, 2, 3, and just close the curly bracket, second, close it. And we have 1, 3, 3, and 1. Once we have all of that, all we need to do is just multiply everything in column and then combine them. That could give us 27x cubed. 3 times 2 is 6 times 9, 54x squared is positive. 3 times 3 is 9 times 4, 36. X also positive. And then 8. So that's pretty much binomial expansion. Right. We have another one here. So again, divide into columns. This to 5, so going to be 6 column. 5, 4, 3, 2, 1, and then 0. 1, 2, 3, 4, 5, 6. Okay. The first one we have just x. The power from that and decreasing. So that's what we have. So the first term. The second term is -2, and this is increasing power from 0. 0 power is 1. To the first power is itself. Second, 4, -8, -2 to the fourth is 16, -2 to the fifth, -32. Right. So the first term raised to decreasing power from n. The second term raised to increasing power from 0. And then the coefficients start from 5, 5, 1, 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, and 5, 5. So we hit 5, second matrix, sorry, 5, and then math, go to probability, option number 3, and then open parentheses, that curly bracket, 0, 1, 2, 3, 4, close. Oh, there's a 5, sorry. There. Right. So the coefficient is that 1, 5, 10, 10, 5, 1. And then multiply in columns. X to the fifth minus 10x to the fourth plus 40x cubed minus 80x squared, 5 times 60, 5 times 16, That's also 80x minus 32. So that's simple enough, right? Next, we just want a particular terms, the sixth term. Now there's a formula for it, but I'm not going to use that. I'll just try to reason. We have the first term, right? X. We're going to raise to 9 power and decreasing. So 9, 8, 7, 6, 5, 4. Let's see how many of them. We want 6 term, right? 1, 2, 3, 4, 5, 6. So the sixth term, we have this to the 4th power. So it's going to be the column that we're interested in. Will be x to the 4th. Similarly, the second term is 3y. 2, 0, 1, 2, 3, 4. Wait. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and then 6. Right? So we want the sixth term, so it's going to be only the sixth column here. So 9, 8, 7, 6, 5, and 4. So then stop at 4. And then 0, 1, 2, 3, 4, 5. That's the sixth term, the sixth column. Also, what we have is these numbers must add up to that. As always, you see. Like 5 and 0, 4 and 1, 3 and 2, 2 and 3, 1 and 4, 0 and 5. All add up to 5. So, this is 9, so they have to add up to 9. And then the coefficient 9, 0, 1, 2, 3, 4, that's also 5. Those two numbers must be the same. Right, what is C? A combination of 5 out of 9. So 9, math, probability, combination. And we take 5 as 126. 126. And then we have 3 to the 4th power is 230. 3 to the 5th, 81 times 3, so 243 y to the 5th, and then that times 243. We have multiply all of this in column. We will have 30,000, 100, 618, x to the 4th, y to the 5th. So in this problem, we only want one term, which is one particular column in the binomial expansion. So the 6th column for this one. Right. The same thing. Next one, well, we want the 5th term. So we start with the 8. So let's see. 8, 7, 6, 5, and then 4. Right. 1, 2, 3, 4. That's the 5th term. So that's the 5th column. X squared times to the 4th power is x to the 8. And then we have the second term, y cubed, positive y cubed. Start from 0, 1, 2, 3 to the 4th. So y to the 12th power. Multiply the powers. And then the coefficient 8, 0, 1, 2, 3, see 8, 4. Remember, those two numbers add up to that number, and those two numbers are the same. Right. So 8, math, probability, combination of 4, 70. Multiply by column, we have 70 x to the 8, y to the 12th power. That's all we do. Right. So with that, we finish the review in cost algebra. By the way, before we start, I just want to write the formula real quick for the binomial expansion, just to make things complete. When we write c n to the r, it's the same thing as writing like this, but the formula is n factorial over r factorial n minus r factorial. So for example, if we want a of 4 for, 9, 5 for instance, combination of 9, 5, we're going to have 9 factorial, 5 factorial, and then 9 minus 5 factorial, so it will be 4 factorial. 9 factorial meaning 9, 8, 7, 6, and 5, and so on, but I'm going to stop at 5, so be that. 5 factorial, that came out nicely, and then 4 factorial is 4, 3, 2, 1, 3 and 2, that's 6, and a and 4 cancel out, so that's 2. So pretty much, sorry, and so we have 7 times 9 times 7 times 2. 9 times 7 is 63, times 2 is 126, which is of course that 126. Alright, so that's pretty much everything that I want to review for the cost algebra. I hope you found this series helpful. Thank you for watching.